Video we look at the anionic polymerization. First, the dissociation. In those examples, typically we take butyl lithium or similar species because this bond can dissociate very easily. The electrons here can go to the carbon, what will yield a very alkalic structure, a very strong base with a counter ion lithium. So this will initiate the reaction. Actually, you see it's a negative charge and we call this a nucleophile. So we also abbreviate it as a nucleophile. Initiation. So we take the nucleophile, note the Lewis structure with the counter ion, and we add a monomer. For example, this one we already do abbreviated to R. In the next video we look at what R have to be to stabilize the negative charge. So this charge go here, or those electrons, we have too much electrons here, so those will flip here and they will yield the first step in the polymerization. Like this Lewis structure and counter ion, so don't forget that one. Yes, propagation step. So exactly as the same in the free radical polymerization and in the cationic polymerization, we draw the structure with some oligomeric structures in the formula. So like this, H, and the active chain end, negative and the counter ion. We add the monomer, and exactly the same as in the initiation step, this negative charge go here and flips to there and will yield the polymer, or next step in the polymerization. So we write it down, N plus 1 because we added a new monomer, and of course the active chain end with the counter ion lithium. That's it. Actually, we don't have to look at the termination step because those mechanisms or anionic polymerization are typically living polymerizations. So if we want to terminate the reaction, we can add a molecule what donates, for example, a proton here, what will cancel out the reaction. So what we will now do, I will abbreviate this structure to just polymeric species N with the negative charge plus the counter ion, so we can use it in a termination reaction if we want to terminate it. So as a chemist, we will have to add an extra molecule to terminate the reaction, and we choose that moment by ourselves. So normally, typically, those are very nice polymerizations because you can control the molecular weight much more easy than in the free radical polymerizations or cationic polymerizations. So, for example, we take something with some protons, methanol, so this one can attack at the proton of the methanol, and the methanol will be methoxy. So we will get this one, so a terminated polymer plus this and the counter ion. And that's it.